These are the instructions for using the Excel file to calculate a confidence interval. And we're actually setting it up to do the different pieces of the formula for confidence interval for the textbook so that you understand how it's computed and you could work it out on a test. So there's a spot to input up to 100 data values of some numerical data. They can be just random numbers or anything. I've only put in 60 data values here. You can type in your own, more than 60, less than 60, up to 100. So once you have the data in there, then there's two types of confidence intervals when you're estimating the population mean. You start with the sample mean, but for the margin of error, it can be based on a z-interval or a t-interval. The z-score, normal distribution, or the t-distribution. How you know is that if you actually have a population standard deviation, even though you're estimating the population mean, if you somehow have an assumption or a previous population standard deviation sigma, we're going to type it in here. And this calculation is going to determine if there's something typed in there, it's going to automatically use the z-score and the normal distribution. But if we leave it blank, then it's going to revert to just doing a t-distribution and using the sample standard deviation in its place. So I'm going to type in a value for population standard deviation to see how that works. The second one we're going to type in is the confidence level. So I'm going to type in 90%. Just type in 90% are already set up for you. So we're going to do a 90% confidence interval, but you could do 95 or 99 or whatever. Now the count, I have 60 data values. I can see that. It's obvious, it's numbered automatically for me. But I don't want to type in that number because if I change my data or delete or add, I want the Excel spreadsheet to automatically know what the count is. And that's the beauty of using a spreadsheet, is that it can calculate and figure everything out when you change the data, everything gets automatically updated. Never compute something yourself and just type it into a cell in a spreadsheet, unless it's just like the raw data values we have here for X. But for the count, there's a function called count. All functions in Microsoft Excel start off with an equal sign. That's how it knows it's an actual function. So we want this cell to equal something. I'm going to start typing the word count, and you'll see different functions. I want just a plain count function. So I choose the count function, and then I choose the data that it's counting. And then I hit enter, and there it shows the correct 60. So you notice if I was to delete a value, it shows as 59. Now I put it back to 60. Now we want the sample mean X bar. To get the sample mean is also known as average. The function here is called average. So we'll just say equals, start typing AV. You'll see the different types of average. You want just a basic average function, and then we select the data values. Of course, if there's more than 60, you would go all the way down to capture all of your data. Actually, it's probably better to, just in case you add in a larger set of data, what I'm going to do here is I'm actually going to capture the entire set of 100, even though some are blank, just in case. Actually, I should do that for the count as well. You notice the count goes to B103. You can hard type the actual cell reference. So it's looking at everything. Okay. Now sample standard deviation, what we're going to start typing is equals ST. There's standard deviation. We want standard deviation of a sample. It's stdev.s. Okay. And then we, again, highlight everything down to whatever entire data set there could possibly be. Now it's going to say the standard deviation to be used. Well, we want the spreadsheet to look and say, hey, if there's a population standard deviation here, then use it. If not, then switch to the sample standard deviation. And that is done by a simple function called if. So we just start typing here, if. We see the if function. And then it asks for the logical test. So if what? And then we click on where this is, E10. If it does. So if there's anything in that box, in that data cell, it will then the next command will tell it what to do. Then you put a comma, and now it's value if true. Well, what should we do? Then we're gonna just equal that value. If E10 exists, then use it. But the value of false. So if E10 doesn't exist, then we're going to click on the sample standard deviation, E14, and that's all we need. You see it's using that. You notice if I get rid of it, it switches to the sample standard deviation. Put it back. Now the variance. We don't really need the variance for the formula, but it's just an extra thing, simple thing in statistics. The variance just happens to be the standard deviation squared. The appropriate standard deviation above here is 150. We want to square that. So we're going to type equals and a direct calculation. We're going to click on that. So it's clicking on whatever number's in here, and then the caret and 2, its second power. That squares it. Now we want the standard error. It's part of the margin of error is something called the standard error. The standard error is the standard deviation divided by the square root of the sample size or count. So we're going to say equals, and then click on the standard deviation to be used, and then click the slash for divide. Now we want square root. So we type SQR, and then you notice there's a square root function, and it's the square root of that count. So we click the count cell, close the parentheses, enter. That is the standard error. Okay, so the standard deviation is 150, but the standard error is 19.4. Now we need to, the other part of the margin of error is the critical value. The critical value can be either a Z or a T. How do we know if it's a Z or a T? Well, it's a Z-score when you have a population standard deviation, which we do. But it could be a T-score if you don't have a standard deviation and you use population 1, and you're using the sample standard deviation's place, you must switch to the T-score, T-distribution. But we're going to get both values anyway. All right. So for the Z-score, there's a function here. Z-score comes from the normal distribution. So we're going to start typing equals norm. It's the norm inverse. Okay. The normal distribution will give you the probabilities. We already know the probability. We need the Z-score that matches with it. That's backwards. That's the inverse. So we type normal inverse, and now we need the probability. The probability is the accumulative area below the Z-score that we want. Well, the confidence level is what's in between the plus and minus Z-scores. But then we also have to include the left tail. So we have to include a little bit extra. So the probability here will equal what's in E11 plus, now since that's 90%, we want the complement of that, which is 10%, which is split into two tails. We want only half the tail. So we're going to have to say plus, and then we're going to have to do parentheses here. And we're going to have to do 1 minus that same confidence level. 1 minus that is the complement, in this case would be 10%. But then that 10% is split between the two tails, so we have to divide that by 2 to get only the left tail, which is 5%. So it's going to give 90% plus 5%, and this will be 95% probability. And we want it for the Z-score, and then it's comma. Now we want the mean. The mean for the Z-score standard normal distribution is exactly 0, and the standard deviation in that normal distribution is 1. So put 0, 1 there, and then enter. And that is the correct Z-score that cuts off 95% cumulatively to the left and the other 5% in the upper tail to the right. All right. Now we need a T-score, which is almost the same thing. Okay, the formula is a little bit different. So we're going to start typing equals and then start typing T, and you notice there's a T inverse. And then we want, again, the confidence level plus in parentheses 1 minus that confidence level again divided by 2, and then comma, but now we just need one other thing that's called degrees of freedom. Degrees of freedom is just one less than the sample size, or count. So we click on count minus 1, close the parentheses. There we go. And now the critical value to be used is going to be either Z or T, depending upon if you have population standard deviation. It's going to be basically similar formula to what we did for the standard deviation to be used here, the if formula, right? So we're going to type in if, select the if the population standard deviation exists, then click on the z-score, E18, comma, otherwise when it doesn't exist, it's false, then you click on the t-value, E19, end. And then the margin of error is simply just the critical value used times the standard error. So equals critical value above times the standard error cell above. And that's our margin of error. And then your confidence interval is already set for you. So what we're saying here is that based on this set of data, which has a sample mean of 358.7, we have 90% confidence, so we're pretty sure that the real population mean, whatever this data set came from, the population it came from, the real population mean mu would fall somewhere between the numbers 326.831 or 390.536. So it goes a little higher and a little lower than the actual sample mean. And that's the way a confidence interval works. Okay. You notice here, what I'm going to do is I'm going to delete the population standard deviation, and it's going to switch to a t-interval. You notice the t-interval is a little bit bigger because it's using a bigger critical value. Actually, no, it's actually smaller because the standard deviation is smaller. The sample standard deviation was actually smaller than the assumed population standard deviation, but the critical value is a little bigger. So it comes out, it's a little bit different of a t-interval. Okay? So that's how we do that, and that's all there is to it.